Hey everyone. Can't see how many people are on here yet, but we're going to give everyone a few minutes to make sure they're on. If you can't hear me, please let me know, or if there's anything else you want to say to me before we start, now's the time. So out of curiosity, where are people calling in from? I'm here in not so sunny Zug, Switzerland, where it has been snowing and raining all day. But I have been able to stay warm with the help of a scarf and the compile times of Substrate. Keeps my computer nice and toasty. That's one of the benefits of slow Rust compile times is that you get some nice warm hands. All right, so we've got a few people on here. I can imagine that some others will trickle in. One thing I wanted to mention is that if you do have a question, I'm going to stop at a few different points of the presentation to wait for questions. If you have a question, instead of typing it in the chat, please go, if you look at the bottom of the Crowdcast screen, there's an Ask a Question button. If you click on that, you can ask a question, or just, if you want to put in a comment, something you want me to address, then feel free to do that. The nice thing about that is when the people watch the video for the second time and they can see the list of questions and then click and go directly to where I answer that question. All right, so what we are going to cover today is a distributed drawing program in Kusama. If you haven't seen my the previous lecture where I talk about programmatically interacting with the Polkadot API, it's not necessary, but it might be useful at some point to watch that. I talk more about the basics of how the Polkadot API works, how you can call it with JavaScript, and a lot of very simple scripts that I wrote to do different things with the blockchain, including transfer funds, call other extrinsics, get chain information like who the validators are and who's nominating whom and all that fun stuff. What we're going to do today is put all of that together into a larger node application. So this node application is going to be a relatively simple drawing program. It's based on Sean Tabrizi's 1 million remarks. I've made some changes and made it even simpler. But if you look at the GitHub repo, and I'll include that in case anyone would like to follow along. Just give me one moment here to paste it. Then if you clone that down, you can watch it, but it's a fork from Sean Tabrizi's 1 million remarks, which has additional functionality like chat that I'm not including here. So I'm going to put that in the chat here if anyone would like to follow along with my version of this. And then I'm going to share the screen now and show you what we're doing. Okay, so thank you. You all get to see the infinite regress of the screen here. So again, if you want to follow along, go to Laboon Substrate 1 million remarks. As you can see, this is a fork from Sean Tabrizi's 1 million remarks. So if you want to see a more complicated version of this, please check that out. So what this program is going to do is we're going to get an image, and by default, it's just going to be a static image. I'm going to run a local substrate chain. So if most people here are probably familiar with Substrate. If you're not, this is the foundation upon which Polkadot is created. It allows you to create all sorts of your own kinds of blockchains. So what I have is Node Template, which is a Kusama style basic Substrate blockchain. So this blockchain, again, in keeping with the theme, is extremely simple. There are no validators. There's just, well, technically there's one validator, but it's a proof of authority chain that's just going to produce blocks. So I'm going to run everything on here, but as you'll see, it'll be very simple for us to actually switch over to Kusama. But as I said, just so I don't have to pay a lot of fees and use up my Kusamas, I am going to just run a local chain here. So what I did was just make sure that I didn't currently have any data in my chain. So that's what this purge chain is. And now I'm just going to run the dev version of the chain. So we can see I've started producing blocks. I can access this just like I could with Polkadot JS, except you'll notice that my block here says 2, 3 as opposed to the higher number. That's because I'm connected to my own local node and not Kusama or West End or any of the other networks. So I'm just connected to my local machine here, running a very, very simple blockchain. So again, I'm starting at a high level of how this is going to work, and then we'll dive into the code. I now have this node program, and there are really two parts to this program, two external connections. So first is just like any node program, it's got, or most, I guess, it's got an interface to the web so that I can connect to it. I also have an interface to my local chain. So you can see connected to chain development. We can also, again, have this connect to Kusama or whatever other chain we want. And we're just sort of following along. Very similar to our block explorer, you'll notice that it's going to be very, very slightly off just because of timing, but pretty darn close. When a new block shows up in Polkadot JS, we're also going to see the block on the node app. So that node app is also just monitoring the chain. And what it's monitoring for specifically is a specific kind of extrinsic. So an extrinsic is sort of the superset of or a superset of like transactions. It allows you to do things with the network. The particular thing that we're going to be, and you can see right now, since there's not much happening on the chain, there's really the only extrinsic that's happening is this timestamp set, which has been successful. This is going to happen every block. What we're going to do is pass in a different extrinsic that's going to indicate that our application should draw something. So as I mentioned, we're connected to the chain. We're also connected to the web. We have like a web port open waiting for HTTP requests to come in. If we go to localhost 80, we're going to see my lovely skills as a front-end designer. You can tell why I'm mostly a back-end person. And this is just a 100 by 100 image that right now has nothing on it. Right now, everything is black. What we're going to do is pass some extrinsics to this, and as it listens to them, it will change the colors of these of the pixels. So just before I go through the example, I'm just going to stop sharing very quickly. And I lost my Crowdcast window. Hold on. Just double checking that no one had any questions. Okay, excellent. So going back to sharing screen. So the particular kind of extrinsic that we're going to listen for is system remark. So there are all different kinds of extrinsics. If you're using Kusama, you'll note that there are a lot more on that. Again, I have a very stripped down chain running, but the particular extrinsic I'm going to talk about exists both on Kusama, will exist on Polkadot, exists on the test nets, exists on dev. It's pretty simple. It's called remark. So system remark allows you to make some on-chain remark. So what that means is you're just going to send some bytes that are going to do something. And I can type in the bytes here. This really can be whatever. If I want to do FF, just because I like to yammer to myself, I've just put something from my account Alice. So my extrinsic was finalized. And now if we look at the block details, you can see that there was a remark made, FF. So we can actually take advantage of this ability to send arbitrary data to do all sorts of different things. If you remember from the previous lecture that I gave on this topic, it's pretty easy to set up basically a listener, like waiting to hear for things. So what we have as part of our application here, you can see here's the two extrinsics, because I sent this extra remark extrinsic, but didn't really do anything. I'm listening to every block, and then I'm going to examine the extrinsics. Okay. Now, the particular kind of extrinsic I want is going to have a special format. And let's run through that. I'll talk more about what that special format is in a minute, but I just want to show you like the example of what actually happens when we do this. So to submit an extrinsic, I'm going to once again click on extrinsics. I'm using the Alice dev account, system remark. And as I mentioned, don't read too much into exactly what I'm typing right now. We'll go through and explain all of this in a second. So you'll notice if I don't type in an even number of hexadecimal characters, hexets, it's not going to let me submit. That's like since you need each of these really indicates a byte. So I'm going to submit the transaction. So you'll notice something different here happened. I found a remarkable image extrinsic. So I wrote this remark in a specific format. Oh, and of course I apparently made a typo. See, never, ever, ever live code or run anything. Always have just documents printed up. Since this was working 5 seconds ago and now it's not. Let me. Oh, right. I changed something. Sorry, I forgot. See, again, never change anything, never do anything really. It's just going to cause problems later. All right, there we go. So we found a remarkable image extrinsic. Remember I said, there's all sorts of different extrinsics. And what we were doing here is reading the chain to see if any extrinsics of the right format came through. And when it does, it's going to interpret this. So at X, Y, 10, color, just our color. And our image is actually going to be updated. So if I refresh this, it's a little bit hard to see. But if you look in sort of the upper left-hand corner, you'll see a green dot. So I know this is Kusama, but we're going to be dealing with some dots today. Sorry, my wife insisted that I give her credit for that joke since she made it up when I was showing this to her. All right, so now that we see what the program is doing, let's just take a second and see why that happened. Okay. So if you look in the code, again, I sent the link there. It's in the chat channel. an index.js. This is the main part of the program. So there's some sort of basic stuff here. Much of this will look familiar if you have either programmed in Node before, or if you watched the previous lecture. We're going to have we'll be listening on on a port. We are going to set up a connection to the Polkadot API. Now let's look at sort of the meat of the application. So we're connecting to the local host. Like I said, I don't want to waste all of my Kusamas sending these remark transactions. I connect to it, just get some information about the node that I'm connected to. So that's why it says, remember, you are connected to the development chain, and here's the version. And I have a separate app, remarkable image. I'll look at that in a moment. And really what we're going to do here, we're just going to subscribe to any blocks that come in on this node. So as soon as we find some blocks, we're going to print out, like, here's the block number that we're on, and then get any extrinsics from that block. So remember, extrinsics are kind of like super transactions, or a superset of transactions. All different kinds of things that you can do. And then printing out, all right, how many extrinsics did we find in this block? Just as a warning, if you want to do some if you're a console log debugger like I am, if you just try to print out extrinsics, you're going to get a lot of data there. So usually I just say, right, how many extrinsics are on here, especially when I'm doing something locally where I don't expect other people to be sending extrinsics into my my local chain. So remember, I'm subscribed looking at every time a block comes by. I'm just checking out, hey, what are the extrinsics in this block? And specifically, I'm going to look for system remarks. So remember, system remark is a particular kind of extrinsic. This is just how we indicate that it is a system remark. And then I'm going to check out what were the bytes that were sent in to there. So remember, when I issued the extrinsic, I typed in this OX1337011010, etc. So the first two bytes here, 13 and 37 hexadecimal, whoops, are actually what we're listening for. So we're going to say if the prefix, if the first two bytes of the string were equal to 1337 or leet, right? We're going to consider that a remarkable image extrinsic. It's a way of indicating in a sort of informal, unregistered way that this is something meant for us. If that occurs, if it's something other than 1337, we assume that remark is not meant for us. But so that's, anything else we just ignore. But if it is something that we want, we're going to try to parse what was actually indicated by the rest of the bytes there. After that, we're just going, after every iteration, we're going to call update the image. So let's look what happens when we do get an extrinsic that we care about. So again, if we have an extrinsic we don't care about, it starts with 9999. I'm going to submit this transaction. We can see that there were two extrinsics in this block, but we don't really care about that. It wasn't an extrinsic meant for us. It was addressed to somebody else. All right, so now let's look at what are we sending in. So those first two bytes, 13 and 37, are just the prefix that indicate that, yes, this is meant for you. But the rest of it actually indicates what should we display on the screen, on the image. So if we go to image.js, so if you're following along, this is in the remarkable subdirectory. So remarkable image.js. And we can see this parse function. So when the program first starts up and we initialize it, all we're going to do is see, hey, does an image already exist at public image.ping? And if so, then we're just going to keep using that particular image. But if not, then it's just going to create an all black image. So that's what this is here. Then we're going to write that image out. So basically, if we start and an image hasn't already been created, we're just going to generate an all black image. And our view is always just going to display. It's the only view that we have is just displaying that black image on a white background. So we now have this parse method that we called. So what we're going to do is look at the everything other than the prefix. So that's what the string is. So if there's nothing left, well, there's no buffer. It means that someone just wrote 1337 and but didn't write anything. So we can't display anything. There's nothing to display. However, if there is something there, we're just going to log to the console that we received a particular string. So we can look up. It might be quicker to, yeah. So we found a remarkable image extrinsic, and after 1337, that the string that we're left is 01001000ff00, which we're actually going to parse in kind of a strange way. But it indicates the x coordinates, the y coordinates, and then the color. So this is a standard RGB, red, green, blue, hex, byte, hex, or 2 hexits, byte, 2 hexits, byte, 2 hexits, byte. The coordinates are actually rather strange. So what you're going to do is they're written in as hex, but read as a decimal. So you can see here that 010, which is, if we separate this, right, there's like x coordinate, these first 3 characters, and y coordinate, the second 3 characters. So they're stored as hex, but the hex value is interpreted as a decimal. So even though 010, would be A in hexadecimal, or 16, like 16 in decimal, we're going to read it as 010 or x10 and y10. So kind of strange. That's the way the original app that I based this off of did it. I have a nice helper function in here that will convert x and y into this format, so you don't have to worry about it too much. But if you're wondering why it's going like that over the wire, that's why. It does actually make it rather easy to read. So you can see this is 10, 10, and then green, 0, 0. So red, 0, green, 255, blue, 0, which would be a straight green pixel at location 10, 10. And if we look at our image, we can see a green pixel at location 10, 10. All right, so let's continue on from there. We have this string, and now we just need to interpret it. So we know that the size is going to have to be in characters. Remember, right now we're looking at it as a string. It's going to be 3 because for the first set of coordinates, the x, 3 for the second, and 6 for the third for the color. If it's not equal to that length, then it's the wrong length. We sent something in the wrong format. So now we're going to chop these up into our x coordinate, our y coordinate, and our the color. If we have any problems doing that, then we'll just say that it's bad info. If we're beyond the realm, says I changed this to just a 100 by 100 image instead of the original's 1 million by 1 million. Then we'll say that it's out of bounds, like you tried to create an invalid color, or it's you tried to write it off the screen or something like that. And print out the image just to let people know where the pixel is. You can see that here. Just print out x10, y10, and then the color number, and then push that pixel into our new pixels and update the image. So remember that we then, at the end of every iteration, we're going to call this update, which all it's going to do is set the pixel color at this particular location to a particular color. So, so this is the basics of how this works. Oops, not my riot. Where's my other? All right. So now let's try to do something a little bit more interesting with this. So we were able to put a dot on there. Why don't we try actually drawing, since this is a drawing program? Now, what we could do is keep looking at Polkadot. Sorry, it's got too many windows here. We could keep calling this here with like, okay, so 11, 11, and let's make that red, right? So 1337, 011, 011, FF 0000, sign and submit. All right, so that went through. Then maybe at location 8012, we'll make a white dot. And then at 3218, we'll make whatever this is, red and green. Oh, look at that, it's beautiful. But as you can imagine, this is going to be pretty slow. Like, it's certainly possible, but you know, we have programs out there, right? We have computers that can do boring stuff for us. So since this is all on, accessing Kusama, or technically, a substrate network, we can interact from the other side, interact with our application over the chain. So we can send in those extrinsics programmatically, as opposed to doing them manually like we just did. So again, if you want to follow along, in the root directory of the 1 million remarks repository is draw.js. But what draw.js is going to do is write a bunch of extrinsics onto the network, and they'll then be read by the other node program we have running, that's reading the extrinsics. So these are going to post the extrinsics. I've got this all programmatically done. We're going to draw a white diagonal line and then a red diagonal line. Okay. Right, so I'm leaving this running here, and node draw.js. So this is just going to take a minute as it goes through. So it's going to keep sending these extrinsics with different coordinates. So we can see here the color is FFF, all Fs, which is white. Our coordinate string is all zeros, so 0, 0. 3, 3, etc. We're doing this with like a computer science 101 of just a for loop, where we send in, we're looping with J, and then we're just passing in JJ here as our coordinates. So I have a draw method that's going to accept a link to the substrate API, the key ring, which, if you remember from our the previous talk, is how we can sign transactions. The particular user that we're going to use, who is Alice, at location x equals j, y equals j, and color OXFFF. Same thing for the red diagonal line. We're going to call with API the king ring Alex, but then max minus j, j, and then OXFF0000, which is red. So let's see how that's coming along. Oh, I see a white line. All right, and then that white line's almost done. Then we'll wait for the red one to appear. All right, so how do this work? Let's delve a little bit more into what we did with connect and the draw functions. So connect is pretty simple. In fact, you'll probably use something like this as boilerplate. It's how we are, just like in our node application, our image drawing application, we have a link to the API. However, we also have a key ring, a Schnorkel 25519 key ring, and we're going to add the Alice user here. The Alice user, if you've never used the Substrate like node template, it comes built in. It's a very standard thing in cryptography to talk about Alice and Bob. Alice is the default, one of the default accounts that is created in the node template substrate chain. So I can just use it by adding this key. If you want to use your real key, you can always read it in from the environment, or even like copy and paste your seed words or your raw seed here. I'm not going to do that because I'm not going to show you all my my real keys. So I'm just then going to return the API keyring and Alice. So connect, like I said, this is pretty simple, and you're going to use, if not this, then these same few lines or something very similar, over and over again. Draw is where I think it gets interesting. So we took, I wanted to just deal with X and Y as X and Y coordinates, and not that weird hexadecimal thing. And same with color. I'm just going to pass in a hex value, and I'm going to then allow that function to split those up for me. So if you look at split color and split coord, they're pretty useful helper functions if you want to do something like this. So split color, just given some integer color, which again you can represent in hex, it's just going to make it a 0 padded byte array. So it's just going to chop this up into bytes basically in hex format. Split coord, slightly more complicated, but the same basic idea. If I just pass in some integers, it's going to put them in that weird pseudo hexadecimal, but reading it as decimal format. So again, you don't really have to care too much about them, but they are useful if you want to interact by taking integers and putting them into these different formats. And print hex, if you look, this is just a helper function, so I can easily print out values as hex values. All right, so draw. I'm just going to, after splitting up color and coordinate, I'm just going to let people see, all right, what is it doing? And I'm now going to call API transaction system remark. So this is exactly what Polkadot JS is doing behind the scenes, right? So if you look at Polkadot JS, what you're doing when you submit the following extrinsic system remark, just another way of interacting with that is by calling the Polkadot API transaction system remark. I then have a byte array. So here I have 0x13, 0x37. So this is the same as the 1337 that I added at the beginning here. My coordinate bytes and my color bytes. So 3 of each. I'm going to assign this extrinsic and send it across the network and wait until it's been accepted and finalized, included in a block and then finalized. So again, all that's kind of abstracted away from me here with just draw, right? So I have this nice little draw function that's just, I can call it, and it will send a message to draw, at a particular location, a particular color, right? Good programming procedures, right? Put everything in nice, easy to use functions. So now if we refresh this, wow, we now have a very early 90s looking X, as well as a few extra dots there. So we could write, you could take this draw program and write some other things with it. You can, once you have this all sort of abstracted away, it'll be no problem for you to make your own drawings with it. Just call draw at different locations with different colors, and you are set to go. All right, so now you may ask, well, what happens if this program dies? Right. Well, if we look in the public directory, the image is still there, so we can always reload it. So you can see it looks kind of like a flag or something. We can always reload that. But what happens if you mess up your backup? Whoops. Image ping is now gone. All right, so I'm just going to restart everything. All right, image not found, image created. All right, so we are starting from scratch. So the reason for that is because we were just waiting for remarks to come past. Here we weren't rereading all of the data that was in the blockchain before. Here we're just listening. So it'd be relatively simple to add additional code to look through the blockchain, right, and add all of this stuff. But right now, all I'm doing, again, very simple. I'm just listening as things come in real time. So does everyone have any questions on how this has been working so far? I don't see anything yet. All right, so like I said, it's relatively simple and straightforward, but you may say, well, this is all well and good for a like a local chain, but what if I want to use this on real Kusama? Well, luckily we can do that. And in fact, once we get this up and running, if you just give me 1 second, then if you would like to send some fees and send some things in the right format, then you can also draw on this application. So let's. I'm going to leave. I'm going to stop everything running. I'm going to kill the substrate node because I'm going to have my image actually connect to substrate. So let me go to index.js. So I have our provider as localhost. I'm going to change that to Kusama RPC. And I'm going to change my Polkadot.js, which you can see it's yelling at me because my local node isn't running right now. Change that to Kusama. So now when I run this, you'll notice that a couple of differences here. First is that my block number is much higher because the Kusama block is much higher. You'll also notice there are some more extrinsics in every block. And this isn't just because other people are using the network. There are just other things in the blocks of besides just timestamp, like finality and parachain stuff. So there are multiple extrinsics that aren't there with my very simple local chain. So all right, now that we're running it, we're listening. Let's try seeing if we can get some dots to appear on here. So right now, remember I deleted this. So we're starting with a blank slate. But I'm going to call extrinsic. You'll also notice, again, there are more things available here. with Bill W3F, my verified account. So if anyone is wondering who that is me. I have been judged reasonable. So if anyone ever says I'm unreasonable, you know that Kusama says otherwise. So I'm going to once again do a remark. 1337, let's say 050, 050, color, how about green? And submit the transaction. So again, you can see why I didn't do this programmatically, as I didn't want to pay a whole bunch of fees to send all my dots. So broadcasting this now. All right. So we see some stuff has happened. If I go to the Explorer, block details, no, I'm not seeing it. Did I not catch it in time? Yeah, I may not have caught it in time. It's okay. We can see here what block it was in. Aha! On block 914350, we found our remarkable image extrinsic. So let's look at that block really quickly. One easy way to do that is with Polkascan. If you go to polkascan.io and go to the Kusama CC3. So we see in this block, aside from the normal extrinsics, we see a message from Bill W3F, which has the remark 1337 050 050 00FF00. So kind of neat. We should have a dot here now when I refresh. Ta-da! All right. If anyone else wants to send a remark and make a dot appear, let me know. Oh, I'm sorry. Oh no! Oh my goodness! I apologize. I haven't been seeing this on this. Forgot to reshare. I apologize, everyone. All right, let me go through that again. So if we go, so I'll just start over here from where I think we were. We're now connected to Kusama RPC and not my local chain. And on my Polkadot JS, I am connected to Kusama and not my local chain. I'm going to submit an extrinsic, just like before. So it's coming from Bill W3F, system remark. I put in the magic prefix 1337. I'm going to, let's say 060, so x coordinate 60, y coordinate 10, and let's make it red this time, FF0000. I'm going to submit this transaction. There's going to be a fee to pay. Just going to verify that it's me. All right, so we now have an extrinsic that has occurred on the network. I can see on my local machine, I found this remarkable image extrinsic. So because it has a 1337, I knew that it was a message for me. Receive string 060 010 FF00. And so if I look at my local node, then hopefully when I refresh this, yeah, so we now see a red dot at x60, y10. So if anyone else wants to submit an extrinsic, we can have it actually display there as well. Yeah, or if not, if you don't want to spend some milli-KSMs for that, that's also fine. But so as we can see here, like the remark is actually really useful. because it's really just a string of bytes that can be interpreted in all sorts of different ways, which means that they're all different kinds of things that you can do with it. So I'm interpreting these raw bytes as as locations and colors, but what others people have done, you can use this as a way to put in document storage, or it's a way, like hashes, proof of existence. You can Bruno, who's a fellow tech ed member, is creating basically a Twitter platform, a Twitter style platform called Chirp to do microblogging. So this remark is it's very useful, and we can do a lot of different things with it very, very easily. Yeah, but of course, just like we discussed last time, there are lots of other different extrinsics that you can call. And anything that you can do here, basically anything that you can do through Polkadot.js, send dots or stake or see nominators or vote, all of this can be done via, virtually all of this can be done via extrinsics. That's how Polkadot.js is doing things behind the scenes. So while it's easy, this Polkadot.js provides a nice interface for you. Anything that you can do from here, pretty much, you can also do via the API programmatically. All right, so that was my distributed drawing program. As always, if you look up in the chat a bit, you can see a link to the 1 million remarks. Once again, I want to thank Sean Tabrizi for writing the initial implementation of this, and I added some additions to it. And if you have any questions, then I will take them now. So remember to click on the Ask a Question button. And I'll apologize once again for forgetting to switch back my screen. Did anyone submit an extrinsic? Oh, someone uncolored my dot and turned it into yellow. So thank you, whoever did that. Yeah, so someone changed the color. All right, very cool. All right, it looks like there aren't any questions, but as always, if you do think of any, please feel free to contact me. I'm bill@web3.foundation or @BillDeBoon on Twitter, or you'll see me as Bill W3F on Riot channels. All right, thank you, everyone, and have a good day.